Hi there, I'm carrying on today with more differentiation. We remember last time we learnt the rule for differentiating polynomials. Polynomials are things that have got x squareds in, x cubed in, you know, the kind of things we see when we think of algebra. So if I have a function, say y equals 9x squared plus 7x minus 5, you should now know that the rule basically says if we want to find dy by dx, you times the power by the front number. In this case it's 18, but then you lose a power. So it's 18x to the 1, but no one ever bothers writing 1. If you have a so many x, now so many x means so many x to the power 1, so that gets times and you get 7, so plus 7. And what's interesting about x to the 1 is when I knock off a power I get 0, x to the 0, and x to the 0 I can ignore. And the other thing you should need to know is that if you have, like here I've got minus 5 disappears. We saw an example of that last time, so here is the answer. This is sometimes written f of x equals 6x to the 5 minus 7x to the minus 2 plus 6. Again, get your head around the fact, times by the power. If we want to find f of x, that is f dash of x. Notice the different notations, 30x to the 4. Here, minus and minus is a plus. 2, 7 to 14, knock off a power. Remember, minus 2 becomes a minus 3. Plus 6, again, a bit like before. If you get a number, so it disappears. There you are. So this is the kind of thing I want us both to do, but we're going to do harder ones, trickier powers. So a brief reminder, remember please that if anything's on the bottom of a fraction, it's really a negative power. So if I'm going to get asked to differentiate that, the very first thing I'm going to do, without even thinking about finding its gradient function, I'm going to just rewrite it as 4x to the minus 2. The x over x squared means x to the minus 2. And now, essentially, I can find dy by dx times minus 8x, knock off a power, to the minus 3. Good. Next one, well, we've got 3 things, but other than the fact that it's 3 things in a row, it's the same idea. If I find dy by dx, it's relatively straightforward. Just be aware that I can't really do it though unless I write this first of all in nicer powers. So let's do that before I do anything. X is fine, obviously. You should know this is x to the 1 on the bottom, so that means x to the minus 1. And this is up to the power 2, so really it's x to the minus 2. And now I can differentiate. X really means x to the 1. Move that to the front, it becomes 1. Knock off a power is x to the 0. And I think I said before, if you ever get an expression like y equals 8x, when you differentiate it, it always just loses the x. It just becomes 8. So here it just becomes 1. The minus 1 comes to the front, and I knock off a power, minus 2. The minus 2 comes to the front, knock off the power, minus 3. Yep, all good. You could rewrite it, by the way, and this is perhaps something that you need to be thinking of. I think in the exam, if it just said differentiate it, and you wrote that, you get it right. But there might be a reason why it's better to write it something like this. And you'll notice here I've just gone backwards again. I said, well, actually, to the power of minus 2 is really over. It's a fraction, and I've rewritten it as a fraction. And this, again, x to the minus 3 becomes x cubed in the bottom. So, I mean, it's the same. And both will get you marks, but there might be some occasions when this is a better answer for reasons that you're going to do something with it straight away afterwards. So I've got 3 examples here. Now these 3 examples include 2 that you need to be aware of, and they include the 2 examples where one is a division and one is a multiplication. And so I've got to do those things first. If I don't do those things, I won't be able to get the answer. But anyway, let's just go with this. First of all, dy by dx is equal to, well, bring the 3 to the front, give me 3x, knock off the power, 2. Bring the minus 1 to the front, it's already a minus, so that way I get a plus x. Notice it's 1x really, but no one's going to write that. to the minus 2. So that one I think was fairly similar. It's very similar to the one we just did. And notice my rewriting of that one if I wanted it as 1 over x squared. But this is the one I mean. I think I've got a bit of work to do first of all. I can't just jump straight in there. It says 3x squared minus 2x cubed plus x to the 4, all divided by x to the 5. So I suppose that means I've got to divide that and that and that all by x to the 5. You might recall the rule that says if I do a number like 9 to the power of 6 divided by 9 to the power of 4, the answer is 9 to the power of 2. You take away the powers. So I'm going to do the same thing here. This becomes 3x. And because it's x squared divided by x to the 5, it's to the minus 3. Minus 2x. What's going on here? I've got 3 minus 5. That's to the minus 2. And I've got x to the 4. Well, I haven't got it's plus x. I haven't got any numbers at the front. So, and it's 4. Take away that 5 is minus 1. Notice again, this has not been differentiated. I still need to do that. But I've managed to rewrite it in a nicer form. So it allows me to differentiate it. Minus 3 comes to the front, times is minus 9 x to the power. I've got to knock off a 1. So minus 4. Minus 2 times that, minus 2 makes plus 4 x to the power. I've got to knock off 1 from minus 2, minus 3. And minus 1 comes to the front. And this one gives me minus x to the minus 2. Oh, yes, I'm just looking at that underneath all my scruffy writing. Yes, and they've, in this answer been rewritten as well. The last one, I've got to multiply this out. So now I suppose I've got to make sure I know what this is first of all. This is 5x to the half. We've already said that square rooting is the same as x to the half. So when I do my multiplications, that's what I'm going to use. So I've got 2x times the 3x cubed, which gives me 6x to the 4. I've got 2x times by this thing, which gives me minus 10x. Now I have to add the powers. That's like power 1 to the extra half means 1.5. That is definitely better written. That's 3 over 2. 5 3s are 15, so I'm going to write plus 15. There's no x's here, so it's just x cubed. And 5 5s are 25, so I'm going to write minus 25. Now again, no x's, so this is just x to the half. And at this stage I can now find dy by dx. What's dy by dx equal to? 4 6's are 24. Notice I just times them together and knock off a power. Minus 12. 3 over 2 times 10. This is like 1.5, so that's 15. If I've got 1.5 and knock off 1, that becomes a half. Do it on your calculator if you're not sure. Do 3 over 2 minus 1, and it'll give you a half. Plus 3 15s are 45. Knock off a power x squared. Minus 25 half. So that's, well, I could write 12.5. I'm going to write 25 over 2, get into good habits for A-level maths. And x to the power, if I knock off 1 from a half, I get minus a half. Let's see what my answer was. 24x cubed minus 15as minus 45x squared. That looks right. So just look out for square roots as well. They cause us problems. You should recall this is the rule. If you have a root, it's 1 over as a fraction. So if we differentiate root x, we just saw one of these, didn't we? I don't know why I'm doing it again, but I might as well just remind you. This means x to the half. And therefore when I differentiate, I get dy by the x equals a half x to the minus a half. A trickier one is always y equals, say, 6 root, cube root, I meant to say, 6 times by the cube root of x. And I want to find dy by the x. Rewrite this as a 6x to the third. Oh, that's not so bad now. Move this down when I differentiate it. 6 times by that third is 2x. But the tricky bit here, I always think, is knocking off 1 from a third. And you should realise it's minus 2 thirds, but it's easy to go wrong on that. So I reckon it's 2x to the minus 2 thirds. What did I get this last one right? A half x to the minus a half, yes I did. And again, notice I'm wanting all the time to try to tidy it up if I can. You don't have to. If there's only one mark, just write that and be done with it. But it might be that it says, now solve this equation using this. And this is quite a tricky thing to solve an equation for, but this might be more manageable. Notice the 2 was on the bottom, so it stayed on the bottom. The x became on the bottom and a root because it was x to the half. So here's my example. Well, first thing I want to do is rewrite this. So I'm thinking it's got a root, so I'm going to say 2x to the half. Plus, it's on the bottom of a fraction, so it's to the power minus. So I reckon it's plus x to the minus a half. And now, and only now, can I find dy by dx. Times 2 times a half is 1. Notice then bother writing that, I just write x to the minus a half, but I knock the power off. Minus half to the front times by the 1 gives me minus a half x. And again, you've got to work out what minus a half minus a whole one is. You should get on your calculator minus 3 over 2. This can be rewritten. Obviously, we put the x to the minus a half on the bottom, so it's 1 over root x, like so. And this, the 2's already on the bottom. The minus means the x is going to go on the bottom. It is cubed, because that's the top number, and it is square rooted as well. And that's what that says. Ding. So a couple of questions. Y equals that. Just differentiate it, dy by dx. Half moves to the front, gives me a half x to the minus a half and a knock off a whole one. And as I've shown you several times, if you ever just get a number on its own, it disappears. That has been rewritten with 1 over the 2, and then the x to the minus a half is the root x on the bottom. We've seen it a couple of times. Oh, this is one of those ones where a couple of things have been divided by the same thing. So my very first job is to divide. Now what am I dividing by? Really, I'm dividing by x to the half. I'm leaving it there, but I'm now going to divide it. So I've got to do 5x to the 3 over 2, and I divide by x to the half. I take away the power. 1 and a half take away a half. I reckon it's 5x. And this one, it just becomes minus 2x to the half. Notice I'm not yet differentiated. All I've done is rewritten it. That's okay. Well, some people just stop there when they do these. They think, oh, well, that was hard. And they stop it and they don't then use it to differentiate. Anyway, I'm going to differentiate. 5x becomes 5. You lose the x. And the minus 2x to the half, I reckon, is it to the minus a half? Oh, it's to the minus half as well. I nearly made a mistake there. So it's on the bottom. So it's minus 2x to the minus a half. So the minuses and minuses are plus. A half of 2 is 1, so I won't bother writing that. And it's minus a half, and I've got to take off a whole one, which is minus 3 over 2. So I think it's that. Yes, it is. And again, notice the minus 3 over 2, I've written it as 1 over x cubed square rooted. A little plenary, just to let you in on some notation. So we can differentiate a second time. And we call them second differentials. And if we differentiate dy by dx, so if I start with y and I differentiate, I get dy by dx, as we know. If I do it again, I then get d2y by dx squared. And that's what this is saying to me. Of course, it can be written as fx. So if I differentiate, I get f dash of x. If I differentiate again, you get f double dash of x. It's not very... I mean, you theoretically differentiate 10 times. I've differentiated 4 or 5 times. So it is not ideal. After a while, it gets a bit boring, right? Dash, 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 dash. But you get the idea. So in this case, we'll just quickly do this. We've got this function. We've got d2y by dx. So I'll write dy by dx. Well, first of all, this is written as a nice power. That's okay. This becomes 15x squared. Knock off a power. Plus a half x to the minus a half. Do it again, d2y by dx squared is 30x minus a quarter x to the minus 3 over 2. See if you can get your head around that. And there's some questions for you. So, best of luck with the differentiation, and any questions, just ask.